All right, welcome back. This is the third part of the first round of videos. This is video series 1-1 on measurements. Third part, we're going to talk about temperature. The other thing I want to point out before we get into our information on temperature is just to be careful. We've talked about mass a lot. We talked about mass in the last two videos, but keep in mind mass is not weight. Okay, mass is the amount of a substance. Okay, mass is the amount of a substance, and we know that the unit for that would be something like grams. Weight, on the other hand, is mass and the effect of gravity. So really, it's the effect of gravity on mass. So, for instance, on the Earth, I have a specific weight. And if I were to go to the moon, where the gravity is much less, the lower effect of gravity on my body would mean that I'd have a lighter weight. I would not weigh as much on the moon. Mass, on the other hand, would not change. The amount of me would stay the same in both locations. Okay, let's talk about temperature. That's really the reasoning or the reason behind this video. We separated it out from the other SI units because temperature works slightly different from the others. It doesn't scale with prefixes like meters, grams, and liters. So we have two different types of temperatures. I mentioned them before. We need to understand the differences before we can learn how to convert them. First of all, Kelvin. This is a scale based on molecular, meaning the molecules, or atomic motion. So what does that mean? Well, what it says is that, generally speaking, if you increase temperature, you increase the motion of atoms. So if you have a cup of water, horrible cup of water, but whatever, and we raise this temperature, there's little atoms, or actually in this case, little molecules of water in there, right? Well, as we raise the temperature of this water, the atoms will start to move around faster and faster and faster and faster and faster. Okay, that's the idea. We'll get lots more into this idea later on in the year. But for right now, understand the Kelvin scale is all based on atomic motion. And what that means is at 0 Kelvin, so that's a 0, at 0 Kelvin, atoms stop moving. Pretty cool. Coldest temperature possible. And because it's the coldest temperature possible, we call it absolute 0. That's a Z, people. Sorry. I'll get better at this. So absolute 0. This is huge. Make sure you understand this concept. This, I guarantee, will be on the test. Absolute 0 is the temperature at which all atoms, all the atoms in all matter stop moving. Okay? Frozen solid, as cold as it can be. Now, Celsius, let's compare it. Celsius is a little different. Historically, Celsius came about first. And it is based on the properties of water. Yes. Properties of water. Okay? Not great writing, but we'll deal with it. So, based on the properties of water, that's what Celsius is all about. So what that means is at 0 Celsius, at 0 degrees Celsius, water freezes. Okay, water freezes. At 100 degrees Celsius, water boils. Okay, so based on the properties of water, 0 degrees Celsius, water freezes. 100 degrees, water boils. That's how Celsius is different. Notice Kelvin is all about the molecules moving around or atoms moving around. Celsius is just about the properties of water. So if we really want to understand all matter and all chemistry, we need to work in Kelvin. If we want to understand how things are related to water in terms of their properties and temperature, then we can look at Celsius. And it turns out that most thermometers that we're going to use in this class, well, actually all the thermometers we use in this class, we'll measure in this scale, and then we'll convert over to this scale. Okay. One other point is notice Kelvin, this is the coldest temperature possible, 0 Kelvin. Okay, what we will find out is that is equal to negative 273. Wow. Negative 273 degrees Celsius. Okay, so negative 273 degrees Celsius is the coldest temperature possible. It is also known as 0 degrees Kelvin. We'll understand why it's specifically this number on the next slide. So let's jump ahead. All right, when we're converting from Kelvin to Celsius, very, very simple. There's a formula, okay? The formula is going to be on the periodic table that you have for any exam. It's on the back side, all right? I will show you this tomorrow, but it's always there for you. All you have to do when you're going to convert from Kelvin to Celsius is go and find that formula. So if we write that down, the formula is K equals, all right, follow so far? 0, or not 0, sorry, degrees Celsius plus 273. That's the formula. Okay, so what does that mean? Well, if they give us Kelvin, so if we're given Kelvin, let's say they told us that we're at 100 degrees Kelvin, okay, then you just plug it in. So it's going to look like this. 100 Kelvin equals degrees Celsius plus 273. And you're going to treat this guy here like he was the x in a math problem. So you're going to solve for Celsius. Now when you do that, you want to get x, or degrees Celsius, by itself. So we're going to subtract 273 from this side. If we do it on the right, we have to do it on the left. So we subtract 273 on this side, right? Figure that out. So you're going to end up with 100 minus 273 is going to give us negative 173 equals degrees Celsius. And this cancels out, right? Because 273 minus 273 is going to give us 0. And we have our answer. So 100 Kelvin is equal to negative 273 degrees Celsius. Now, let's say that they gave us Celsius, and they said that we had 50 degrees Celsius, and we want Kelvin. Well, we still plug it in, okay? So this, we're going to plug into there in the formula. So the formula is going to read K equals 50 plus 273, which equals 323 Kelvin. Don't forget your units. As easy as that. So, what is the magic number when it comes to converting from Kelvin to Celsius? This guy right here, 273. If you forget it, remember, this is found, actually, really this, it's on your P table. Okay? There's never an excuse for not being able to convert from Kelvin to Celsius because the formula is on your periodic table. All right? All right, let's do some practice problems. I do not have the periodic table accessible here. I don't have a picture of it for you. So I'm just going to rewrite the formula that is on the back of your periodic table right up here. So that would be Kelvin equals degrees Celsius plus 273. Okay? And just to show you, I know I said I'd show you tomorrow, but this is the periodic table. Okay, this is the one that we have in class, and if we look all the way down here at the bottom, absolute temperature conversion. It's right down here. All right, now we have our formula written down. We are good to go. All we need to do is solve some problems here. So remember, we plug it in. This, they're giving us Celsius, so we're going to plug it in right there. So K equals 110, because that's what they gave us right here, 110 Celsius plus 273, which means we have 383 Kelvin. Make sure you write your units. There's no naked numbers. They always need units, okay? Then let's continue on here. So we have negative 10 degrees Celsius. We plug it in up here. So we're going to get, again, Kelvin equals negative 10 plus What's the number? Oh, 273. It's in the formula, right? So the only number we're plugging in is right here. We took this Celsius, we plugged it into our formula, add 273. That's going to tell us we have 263 Kelvin. No naked numbers. Make sure you record your units. Moving on here. 65 Kelvin. Now this is slightly different. They're giving us Kelvin instead of Celsius. So that means we're going to plug this number here in on the left side of the equation. So it's 65 equals degrees Celsius plus 273. Okay, to get Celsius by itself, that's how we solve. We're going to subtract 273 from this side, and we're going to subtract 273 from this side. These will cancel out. We're left with degrees Celsius equals 65 minus 273, which is going to be negative, what is that? My brain is just frazzled right now. I believe that's negative 208. Okay. Now, the remaining two, these guys here, that's your homework, okay? Right now, you're going to sit down and you're going to figure out these two answers. Tomorrow at the beginning of class, we're going to go over them. But do them now. Don't cheat yourself. Make sure you practice. That way, you've got two problems to do and you're ready to go for tomorrow. All right? See you in the morning.